Hi my friends, today we try to model this sheet metal part which I called double curved because it has one curve and another one made of sheet metal. You have to observe the bend radius everywhere around the part. Since the drawing has the thickness of 0.5 millimeters, the internal curve is 0.5 millimeters and external is plus 0.5, so it is double of the thickness. This is the default setting for sheet metal parts, and we apply them even if we don't know this. When you create a bend, you obtain that radii for internal and external bending. So, keeping this in our mind, we'll try to model this by starting with this contour. Yes, I used as the sketch for the flange, contour flange. You see, this is the tool to create such a thing. Knowing this, let's start. We create this contour with the radius 40 after a small vertical line, and then another horizontal line of 30.5 millimeters long. 30 degrees is the angle between these two straight lines. Yes, dimension is 50, 59, and you know everything. New sheet metal part, XY plane. We start from the origin up, then I keep pressed the left button to draw an arc, then a line, a tangent line, horizontal, and that's all. Dimensions, radius 40, home, angle of 30 degrees, is this dimension, and 30.5 is here. One dimension is necessary, this dimension of 59. This is the contour for creating a flange, a contour flange. Finish sketch. We have the tool here, so the only contour is taken as a profile. I don't care about the thickness. Let me show you. Sheet metal defaults is 0.5. Yes, I don't need to change this. This is by default. Good. So I come back, I extend this into, no, the first is the orientation of the thickness. The thickness is up and I want to be is mid. I want to be down, not up but down. You see, this line to be the upper face, and the extension is here of 70 millimeters. If you take a look here, you see 70. Yes, 70 symmetrical, as you can see. Okay, very, very interesting. And you see here the two radius. I didn't create this radius. I draw this line, and we obtain a radius which can measure M from Monaco, and you can measure this radius is 1. This radius is 1 millimeter. The inside is the thickness. Click here and select the inner arc, which is this, and the radius is 0.5. This is by default, my friends. The inner line, the inner radius is the thickness, the outer is the radius plus the bend radius plus the thickness. Okay, you will see that we emphasize this because we need to use them. Now we have to create this cut. You see this one with the dimension you see. Practically, we have to create a sketch as this one, placed on the plane YZ or a plane of the part. Yes, this one, with 3 dimensions, 25, 7.5 and 27. Let's make this sketch. This face, sketch a circle with the radius of 25 on the same vertical with the mid, with the center. This is the center point of the part, not this one. A dimension from this line to this icon, not another. This one, 27. Fully constrained. But there are also 2 tangents, as you see in the sketch. Tangents at 7.5, symmetrical because everything is symmetrical here, as you can see in the drawing. So we keep pressed the left button and we have a tangent. Yes, if you want to draw a tangent in the other direction, you have to go through the point, through the tangency point. Yes, look here, I go through the point to the other direction. Place it somewhere here. Then project as a construction line the upper line, this one, not this one, to cut or trim the tangent. Then we create the other one, line, keep pressed the button, you have a tangent, and go to the upper. Yes, but not as a construction line. I disable this, I select the line and I make it not construction line. Good. Now to create a symmetry here, I simply make equal these two tangents. Yes. Trim the rest of the circle and we play our dimension here. From this point to the end of the construction line, 7.5 is respected also to the right. We draw a last line to create a closed contour. Finish sketch, cut, not the depth of the thickness, but the depth of all. The direction is okay. Okay. Now we can create the flat pattern, and as you can see, it works. Let's select the material, stainless steel, and now the next step is to create this second curved face. To do this, we can try to use the tools from the sheet metal ribbon. These tools. What tool do you think is good? Contour flange. We used it by drawing a single curve made of some entities, and now we can make the same thing. Before anything else, we delete the flat pattern to have no problems with it in any way. Then we select this tiny face to create a sketch. I make this not normal but construction. And then we know that this is a number of 3 entities, 2 lines and an arc. I draw this contour here, keeping the left button of the mouse pressed, and then tangent. I project the arc as a construction line, and I identify the ends of this arc with the ends of the former arc. This, and also the ends of the lines, to have something very clear without any problems. Now, having this contour created by us, not projected, because it is not acceptable to be projected. Finish sketch. We have the contour, so theoretically we can apply contour flange. You see the line was selected, but I cannot create, I have no access to OK. I don't have a double line here, so nothing is possible to do in order to create this contour flange. This is why we go to the 3D model tools. We did this in some other tutorials. You can see them. And we edit the sketch by applying offset with the distance of the thickness. Thickness is a parameter. Yes, thickness. And when I tap the key S, look what happens. Now is black. So I have a distance of the thickness. I draw end lines to both ends. And I finish. Now I have a close contour. Let's see what happens if I want to extrude. Oh, it is very good. But I want to be to the right and join, not cut. To the next surface of the part. Okay, we have what we want with one or two exception. We don't have here the radius of bending, which is equal with the thickness, and here double thickness. So I select this line and I apply fillet with the dimension of the thickness again. We know this from our experience with sheet metal parts, plus the other contour which has double thickness multiplied by 2. Okay, now the part is just like being created with sheet metal tools. Yes, I cannot create flat pattern. Look what happens. Error. Normally. Cancel. I know that I cannot create a flat pattern from this, but there are a lot of objects, sheet metal objects, which cannot be flatted. The next step is to cut, to create this cut. I will use dimensions radius 15, distances 30 and 20. Okay, the plane is XY, this plane. We create a sketch with a circle with radius of 15 placed at 20 from the left and the same circle now 30. Finish sketch, extrude or cut in both directions, all, both. Okay, my friends, this is the part. Yes, not every feature can be made with sheet metal tools. This is the conclusion. So we can use also the 3D model tools, because in any cases the flat pattern cannot be created for some parts. We met this situation in our former tutorials. Take a look at my previous tutorials. The properties of this part is the volume. The volume is, as you can see, copy, we open this blank, slightly different from the previous one, so I keep this, which is made together with you. Okay, you have to reach the end with this volume. That's all for today. Thanks for watching. Bye bye.